Hi guys, so you just the other day learned synthesis and decomposition. Today you're going to break down single replacement and double replacement. All right, so let's just get started. Before we dive into single and double replacement, I do want to review how to determine charges when things are bonded together, because this is very important for single and double replacement. So we are going to reverse the crisscross. Reverse the crisscross. So let's take sodium chloride as our first example. Na has 1 and chlorine has 1. Na is a metal, and we know metals take positive charges. So this 1 from the chlorine reverse crisscrosses up, and sodium takes a +1 charge. And then the 1 next to the chlorine, next to sodium, sorry guys, the 1 next to sodium is going to reverse crisscross up, and that means chlorine has a -1 charge. Chlorine is here on the periodic table. You can see it takes a negative charge, and it takes a negative charge because it is a nonmetal. So that means sodium has a +1 charge. Chlorine has a -1 charge. All right, let's reverse crisscross lithium sulfide. There is a 1 outside the sulfur, as we know, so the 1 will reverse crisscross up. Lithium will take a +1 charge. You can check that with the periodic table there. Since it's a metal, it takes a +1 charge. Sulfur is going to take that +2 charge. Since there's a 2, that was crisscrossed down. So this means that lithium takes a +1 charge, and sulfur takes, not a +2, a -2. Sorry guys, takes a -2 charge. And you can see sulfur on the periodic table has a -2 charge. Okay. And lastly, let's do magnesium oxide. So right now, magnesium has 1 and oxygen has 1. So it would seem that magnesium would take a +1 charge and oxygen would take a -1 charge. However, if we look at the periodic table, oxygen takes a -2 charge. We want an overall charge of 0, which means that magnesium will also want to take a +2 charge because 2 minus 2 makes 0. So in fact, when you have a simplified compound, you need to check charge for simplified compounds, okay? And again, metals are positive. Nonmetals are negative. All right. We are going to be using the reverse crisscross a lot in this slideshow, okay? Let's dive on in. Single replacement. So step 1 is to determine metals and nonmetals. Metals, we're going to box them in. Nonmetals, we are going to circle them. So let's take a look. Copper is a metal, so it gets boxed in. Silver is a metal, so it's going to be boxed in. And then NO3 is it's a grouping of nonmetals. You can keep nonmetals together. Okay, so we have Cu, Ag, NO3. We've determined that we have 2 metals and 1 grouping of nonmetals. Excellent. All right, let's move on. So step 2 says that we need to swap the 2 of a kind, meaning if I have 2 metals, they swap. If I have 2 nonmetals, they swap. So again, my copper was a metal, my silver was a metal, and my NO3 was a grouping of the nonmetal. So this means that my copper needs to swap with my silver, and my silver needs to go where my copper was. So my silver needs to go where my copper was, so it should be Ag alone plus CuNO3. You can take the 3, you can take this subscript, because it's a grouping. Take the subscript for polyatomic ions. Technically, if there was a subscript out here, you wouldn't take that one. So you can take the subscript in the parentheses for polyatomic ions, okay? All right, so we swap the 2 of a kind. So if we have 2 metals, we swap the metals. If we have 2 nonmetals, we swap the nonmetals. So we have 2 groupings of metals, the copper and the silver. They swapped places. So the silver stood alone and the copper is now bonded to the NO3. Okay. Next step is to determine charges. So I had my copper, my silver, my NO3, creating Ag plus CuNO3. Okay, so we need to determine charges. Looking at my reactant side, I can use them to help me determine charges for my product side. Okay? So I have an imaginary 1. Let's do a different color. I have an imaginary 1 for my silver and an imaginary 1 outside for my NO3. So that means if I reverse crisscross up, my silver takes a +1 charge. And if I reverse crisscross up, my NO3 takes a -1 charge. So NO3 is a -1. Good. Now, copper can take a +2 or a -1. In this case, it's going to take the +2 charge, the +1 charge, because 1 minus 1 equals 0. Good, so now we determined our charges. So copper is a +1, NO3 is a -1, and that NO3, this came from the reactant side. Okay, so now that we've determined charges, our next step will be to crisscross the charges. Let's take a look. So our next step is to crisscross the charges. Again, my copper was the metal, my silver was the metal, my NO3 was a non-metal, my copper went to where my silver went to where my copper was, which gives me silver standing alone plus the CuNO3. From the reverse crisscross, I know that silver was a +1 charge and the NO3 was a -1 charge, so -1, and my copper is going to take a +1. So now we're going to crisscross. So the 1 for the NO3 comes down, so it should be Cu1, and then the +1 for the copper comes down to the outside of the NO3. So NO3, you can think of this in parentheses, and that 1 goes on the outside. And then we just write everything else we have. Okay, fantastic. So we just crisscrossed our charges. The next step will be to simplify our charges, which we don't have to do because they are simplified down to their lowest form. Again, it's Cu1NO3 with those parentheses and that 1 on the outside. 1 and 1 are the lowest form, so we don't need to simplify. So we don't need to simplify. And then step 6 will be to balance. Okay. So we have, let me write out our equation again. Ag plus Cu1NO3 1. All right, so I have Cu, Ag, N, and O. We have Cu, Ag, N, and O. Cu is 1, Ag is 1, N is 1, O is 3. Ag is 1, Cu is 1, N is 1, O is 3. And we are balanced just by chance, but that's fantastic. All right, cool. Let's go do some practice. Example 1. So we have Br2 plus Ki. So Br is a non-metal. Potassium is a metal. That's hard to see, it's the same color, so I'm going to make that a lighter blue. And I is a non-metal. So in this case, I have 2 non-metals. So they are going to swap. So this means that my Br is going to come hang out with my K, and my I is going to come hang out alone where the Br is. So I should have I standing alone plus K bonded to Br. And looking at the reactant side, I have a Ki. There's 1 and 1 for each. So that means K takes a +1 charge, I takes a +1 charge, so K is a +1. And looking at the periodic table, Br is also a -1, so now we crisscross. So it's going to be K1, Br1 plus, oh, it's I2. It's diatomic, that's my fault. I'm sorry, guys. I'm going to erase this. If you need to, write it lower. Plus Ki. All right. So we have Br2 plus Ki makes I2 plus Kbr. So we have swapped, we determined metals, nonmetals, we swapped the 2 of a kind. Then we found the charges, we crisscrossed the charges, And now we need to simplify. We can't because 1 and 1 is as low as you can go. So now we must balance. So we have BR, K, and I, BR, K, and I, BR 2, K and I are 1, BR is 1, K is 1, I is 2. So my suggestion will be to take times 2, put 2 here, 2 times 1 is 2, 2 times 1 equals 2. Excellent. And then we need to put a times 2 here, 2 in front of the ki, 2 times 1 is 2, and then 2 times 1 is 2. And now we are balanced BR 2 and 2, K 2 and 2, I 2 and 2. Good. Okay, I hope this is making sense, guys. Nash, stop barking. Oh, sorry, Nash was barking. All right, let's move on to the next example. Example 2. So, let's take a look. Magnesium is a metal, so we're going to box it in. Copper is a metal, and then SO4 is a metal. And actually, guys, you know what? I'm going to rewrite this because it should be, this was my mistake, it should be magnesium plus copper, and then it should be SO4 in parentheses. So once again, after you rewrite that, it's magnesium and copper are the metals, and SO4 is a nonmetal. Since I have 2 metals and 1 grouping of nonmetals, the 2 metals are going to swap. So the magnesium is going to sit where the copper is, and the copper is going to come out and sit alone where the magnesium is. So the copper is alone plus the magnesium hanging out with the SO4. Here, actually, I'll put the SO4 in green, so it's the same. And we can put those parentheses and put that little 1 there. Well, maybe we should wait on that, actually. Sorry. The little 1, though, can go there. Perfect. So if we take a look at this, copper has a 1, and the sulfate on this side has a 1. So this means that sulfate's taking a -1 charge, and the copper is taking a +1 charge. So my sulfate's taking a -1 charge, so over here it has a -1. And if we look at the periodic table, the magnesium actually has a +2 charge. And now if we crisscross, the 1, oh no, the 1 crisscrosses down to the magnesium, so I have magnesium 1, and then SO4, oh, my pen's acting odd, oh goodness, well, let's just keep going and see how this works out. And then the 2 crisscrosses to the outside of the SO4, no, okay, oh my goodness, plus Cu, and then we have Cu, SO4 with the 1. Oh, it's so messy. I'm so sorry, guys. Plus, no, plus Mg. Okay, so we have determined our metals and our nonmetals. We have swapped them, determined charges, crisscross the charges, and now it is time to balance. That to be a magnesium. God, this is bad. I have to restart this program. Okay. Magnesium, copper, sulfur, oxygen. Magnesium, copper, sulfur, oxygen. Magnesium has 1, copper has 1, sulfur has 1, oxygen has 4. Magnesium has 1, copper has 1, sulfur has 2, and oxygen has 8. So it looks like we need to turn my sulfur into 2 by multiplying by 2. So 2 comes out here, so it's 2 times the copper, which makes 1, 2 times the sulfur, which makes 2, and then 2 times the oxygen, which makes 8. All right, and then this needs to turn into a 2. Copper times 2 is 2. Put out that big 2 in front. Okay. Awesome. Let's move on to example 3. So for example 3, we have Zn plus HCl. So let's label our metals and nonmetals. So Zn is a metal. H is technically a nonmetal, and so is Cl. All right, well, this is confusing. How can H and Cl both be nonmetals, but together? Well, they're covalent, so that's okay, but how are they going to swap? So this is the trick, and this is why I'm doing this example for you guys. Zinc, since it's a metal, it takes a positive charge. Hydrogen, oddly enough, even though it's a non-metal, it takes a positive charge. So in this case, we are going to actually box in our hydrogen because it is going to act like our metal. Okay? So because hydrogen takes a positive charge, it is metal acting. All right, so we can write that up here. Because H takes a +1 charge, it is metal acting. Okay, so this means that my hydrogen and my zinc are going to swap places. So my hydrogen will hang out alone, and my zinc is going to bond with the chlorine. Good, okay. And now looking at the periodic table, we know that zinc takes a +2 charge, and chlorine takes a -1 charge. So if we were to reverse crisscross, I mean not reverse crisscross, if we were just to crisscross, the 1 would come down to the zinc, and the +2 would come out to the chlorine. Oh my goodness, guys, I'm sorry, I'm clearly losing my mind. And then plus the hydrogen, which I want to just draw attention that it should be diatomic, so that 2 should be there, becomes Cn plus HCl. Okay. So step 1 was determine metals and nonmetals. Step 2 was to swap them without the coefficients. Step 3 was to determine charge. Step 4 was to crisscross. Step 5 was to simplify. We can't simplify, so step 6 is to balance. Zinc, hydrogen, and chlorine. Zinc, hydrogen, and chlorine. So I have 1 zinc, 1 hydrogen, 1 chlorine. I have 1 zinc, 2 hydrogens, 2 chlorines. So I need to make my chlorines 2 by multiplying by 2. Put a big 2 out front. 2 times the 1 hydrogen makes that a 2 as well. 2 times the 1 chlorine makes that a 2. So I've got 1 zinc, 1 zinc. Good. I've got 2 hydrogens, 2 hydrogens. Good. 2 chlorines, 2 chlorines. Excellent. Okay. So those are your 3 examples of single replacement reactions. You know they're single replacement because they have 3 molecules in them or 3 sets of things, 2 metals, 1 nonmetal, or 2 nonmetals and 1 metal. All right, 3 sets. We're about to dive into double displacement or double replacement, whatever you want to call it, both work. And we're going to go through the 6 steps you need for those and then the 3 practice problems. All right, so let's dive on in. Double replacement. So double replacement, step 1 is to determine metals and non-metals. Again, my metals are going to be boxed in. My non-metals are going to be circled. So let's take Ki, so potassium iodide, plus lead nitrate as our examples. So Ki, K is my metal, iodine is my nonmetal. Lead, boxing that in because lead is the metal, and NO3 nitrate is the nonmetal. Good, okay. Next step. Step 2, once you determine your metals and nonmetals, you need to swap the metals. Keep the nonmetals in their place. And you'll see why this is really helpful. So again, my potassium is the metal, my iodine is the nonmetal, the lead is the metal, and the nitrate is the nonmetal. So now it is time to swap them. I'm going to swap my metals. It's just easier. They're simpler, they're smaller, there's not as many. Like Pb is smaller than NO3, so it's just easier to move the smaller things than it is the larger things. So let's just move our metals. So the K is going to go hang out with the NO3, and the Pb is going to hang out with the I. So what this means is when you rewrite this, I want you to write the NO3 where it is without its outer 2 subscript, and I want you to write the I where it is. And now we're just going to change the positions of the K and the Pb. So the K is going to move and sit with the NO3, and the Pb is going to swap out and sit with the I. Okay, good. So we have determined metals and nonmetals, we have swapped the metals. Now let's move on to step 3. Step 3 is to determine charges from the reactants and place them in the products. Okay? So we're going to determine the charges from the reactants and place them in the products. I'm just going to walk you through it. So K again is the metal, I is the nonmetal, Pb is lead, it's the metal, NO3 is the nonmetal, K and Pb swapped places, I and NO3 stayed the same. All right, so I have Pb with the iodine plus the potassium plus the nitrate. And now it's time to determine charge. So let's take a look. There's a 1 after that K, and there is a 1 after that iodine. So we reverse crisscross. Potassium takes a +1 charge. Iodine takes a -1 charge. So I'm going to carry those over to the product side. Again, guys, this is the reactant side, and this is the product side, okay? So I'm going to carry those 2 charges over to the product side. So my K is a +1, so I'm going to find potassium, K, it's a +1 charge. I is a -1. Good, okay, now let's move on to the next compound. So I see the 2 outside the NO3, and there is a 1 between the lead and the nitrate. So if I reverse crisscross, that 2 swings up and means that lead takes a +2 charge. And that 1 after the lead swings up and tells me that nitrate takes a -1 charge. So lead takes a +2 charge, and nitrate takes a -1 charge. So for double displacement, you will get your charges. Charges come from the reactant side. Charges come from the reactant side. Okay, let's move on to step 4, which is crisscross. So step 4 is to crisscross. Crisscross charges. So again, I'm just gonna box in my metals, circle in my non-metals. Again, we swapped potassium and lead. So we had the iodine and the NO3. The iodine had the lead and the NO3 has the potassium. Gotta put my plus sign. And then we saw that this was 1 and 1, and this was 1 and 2. So this means that my K took a +1 charge, and my I took a -1 charge. Lead took a +2 charge, and NO3 took a -1 charge. All right, now we can crisscross. So the -1 for the iodine swings down, so it's going to be lead 1. And the +2 swings to the outside of the iodine, which makes my iodine 2. And now my -1 swings down to the potassium, making it potassium 1. And the +1 swings out to the outside of the NO3, making it NO3 to the 1. Okay, and let's write in the rest of the reaction. So I have PB, NO3 with the 2, plus the Ki. Okay, so we just crisscross our charges to get lead 1, iodine 2, potassium 1, NO3 1. Step 5 is going to ask you to simplify the charges or the tiny subscripts. We don't need to worry about that for this one. The small numbers are as small as I can get. So step 6 is going to be to balance. So let's just balance, and I will just rewrite this equation for you guys. So it is PB, PBI plus K, NO3. PB took a +2 charge, so my I is going to take a 2 charge. My PB is taking a 1. K took a 1, and NO3 took a 1. All right, cool. So now let's balance. So I have K, I, PB, N, and O. K, I, PB, nitrogen, and oxygen. All right. K is 1, iodine is 1, lead is 1, nitrogen is 2, oxygen is 6. K is 1, iodine is 2, lead is 1. Oh, weird. Changing colors on me. Lead is 1, nitrogen is 1, oxygen is 3. So nitrogen is 2 on my reactant side and 1 on my product side, so I think it makes most sense to multiply by 2. put the 2 out in front of the nitrogen, it's going to change the potassium. 2 times 1 is 2. 2 times 1 is 2. And 2 times 3 is 6. So now it looks like that my iodine is 2 and my potassium is 2. So it makes sense to put a 2 out in front of the iodine. And the potassium, so 2 times 1 is 2. And 2 times 1 is 2. So I have 2 and 2 potassiums, which are K. 2 and 2 iodines, which is I. 1 and 1 leads. 2 and 2 nitrogens, which is N. And 6 and 6 oxygens, which is O. So we are balanced. And now I'd like to take you through 3 practice problems, and then you should be ready to go to do your own practice. All right, so let's dive into these 3 practice problems. Example 1. Okay, so the first step is to determine metals and nonmetals. So barium is a metal, chlorine is a nonmetal, magnesium is a metal, SO4 is a nonmetal. Next is to swap the metals, keep the nonmetals where they are. So I'm going to write my chlorine without a subscript and write my SO4, because technically this SO4 is in parentheses, so its subscript's a 1. So we just don't bring the 1, we just keep the SO4. And now we're going to swap the barium for the magnesium. So the magnesium is going to swing out and bond with the chlorine. Okay, it's swinging out, bonding with the chlorine. And the barium is going to swing in and bond with the SO4. Okay, now we need to look at our reactant side to determine our products. So I have a 1 here between the barium and the chlorine, and a 2 for the chlorine. The 2 reverse crisscrosses up, which tells me that barium takes a +2 charge. So I'm going to put that over there on the product side. And the 1 crisscrosses up, which tells me that chlorine takes a -1 charge. I'm going to put that over there on the products. Good. Now, looking at the next compound, there's a 1 between the magnesium and the sulfate, and there's this 1 on the outside of the sulfate. So the 1 reverse crisscrosses up and tells me that magnesium is taking a +1 charge, and this 1 reverse crisscrosses up and tells me that sulfate is taking a -1 charge. Now I want to draw attention to this. Magnesium, if we were just to check this on the periodic table, we would say that magnesium actually takes a +2 charge. And since we want to get 0, we need to change that -1 and make it a -2. This MgSO4 is a simplified form. This is a simplified form. So we need to recognize that Mg on the periodic table is a +2 charge, which means that SO4 needs to be a -2 charge. So Mg takes a +2 charge, and SO4 actually is a -2 charge. Okay, good. And now we crisscross. So let's crisscross them down. The -1 swings down to the Mg, so it should be Mg1. The 2 swings down to the chlorine, so it should be Cl2 plus. The 2 swings down to the Ba, so it should be barium2. And the 2 of the barium swings down to the SO4, so it should be SO4, 2. Okay, now we can simplify. So this 2 and that 2 can actually simplify down to 1 and 1. So we can take a 2 out, so it should actually be just BaSO4 plus Mg1 Cl2 creates MgSO4 with a 1 plus BaCl2. So let's just stop and rewind and review what we've done. We have determined metals and nonmetals. We have kept our nonmetals where they are and have swapped our metals. We then determined charges on the reactant side and placed those charges on the product side. We crisscrossed our charges. We've simplified the small subscripts, and now it is time to balance. So I have BaCl MgSO. It's getting tiny, but BaCl MgSO. My Ba is 1, my Cl is 2, magnesium is 1, my sulfur is 1, my oxygen is 4. My Ba is 1, my Cl is 2, my Mg is 1, my S is 1, my oxygen is 4. And if we look, barium is 1 and 1, nice job. Chlorine Cl is 2 and 2, nice job. Magnesium is 1 and 1, great. Sulfur is 1 and 1, oxygen is 4 and 4. Okay, perfect. Let's move on. Next example. All right, metals versus nonmetals. So we've got my Ag, silver is a metal, NO3 is the nonmetal, potassium K is the metal, CrO4 is the nonmetal. So now we're going to swap places. The Ag is going to go hang out where the K is. K is going to hang out where the Ag is. And the NO3 and the CrO4 will hang out where they are. So the Ag is going to swing in and hang out with the CrO4, and the potassium is going to swing out and hang out with the nitrate. Good. And now we get to determine charges. So there is a 1 between that silver, and technically there is a 1 on the outside of this nitrate. So the 1 reverse crisscrosses up, means that silver takes a +1 charge. And the 1 between the silver and the nitrate reverse crisscross up, means that nitrate takes a -1 charge. Good. There is the 2 between the potassium and the chromate, and technically there is a 1 on the outside of the chromate. So the 1 reverse crisscrosses up, potassium takes a +1 charge, and that 2 actually reverse crisscrosses up, means that chromate takes a -2 charge. Good, so now we reverse crisscross, so now we're going to crisscross our charges on the product side. So the 1 swings down, so I have potassium 1, and the +1 swings down, so I have nitrate with that 1 on the outside, good, plus I have my silver. Oh, well, let me crisscross, sorry guys. The 2 comes down, so I've got silver 2, so Ag2, and the +1 comes down, so I have CrO4 to the 1. Okay, so we determined metals and nonmetals. We have we've determined metals and nonmetals. We've kept the nonmetals where they are. We swapped the metals. We determined charges on the reactant side. We put them on the product side. We crisscrossed the charges on the product side. The next step would be to simplify. They are as simplified as they can be. So now we are going to just balance. So I have silver, nitrogen, oxygen, potassium, chromate, and that's it. So I have silver, nitrogen, oxygen, potassium, and chromate. My silver is 1, my nitrogen is 1, my oxygen is 3 plus 4, which makes 7 because that 3 and that 4. Potassium is 2 and chromate is 1. My silver is 2, my nitrogen is 1, my oxygen is 3 plus 4, which makes 7. My potassium is 1 and my chromate is 1. So it looks like my silver is 2 and 1. So let's multiply this by 2. Put the 2 out in front. 2 times 1 is 2. Good. 2 times 1 for my nitrogen is 2. And 2 times the 3 is 6. So I have 6 plus 4, which makes 10 oxygens. Good. And now it looks like my nitrogen has become a 2 and my potassium's a 2. So let's make my potassium a 2 times 2 equals, that 2 is going to go out in front. 2 times 1 is 2. 2 times 1 for the nitrogen is now 2. And 2 times 3 is now 6. 6 plus 4 makes 10 oxygen. So I have 2 silvers, AGs, 2 nitrogens, 10 and 10 oxygens, 2 and 2 potassiums, and 1 and 1 chromates. So we are balanced. I'm going to stop the video here because it is a very long video, and I thank you all for being so studious and patient and willing to learn this material. I want you to try example 3 on your own. When you've finished, call me over, right, and I will check it. So I want you to do example 3 on your own, and I will check it. Or if you would like, we can do it as a class, but you need to let me know, okay? But this video already is very long, so I want you to try this on your own, okay? Good work, guys. I know this is the toughest stuff that we've done, so I'm really proud of you. Stay strong, keep working through it. You've got this.